Hi, today I am going to discuss about vectors and scalars. Vectors and scalars. First one we'll consider vector or vectors. We know about physical quantity. For the first unit, I taught you physical quantity. Physical quantity is a one which has a certain definition, or we said with that which can be measured. So it's a physical quantity. Then we discuss about basic ones, right? And all. Here, vectors or scalars are concerned, they are physical quantities. Physical quantities which has physical quantities means anything what we consider, all the things, mass, length, speed, all are physical quantities. We can consider into or split into two. One is vectors, second one is scalars. So vectors are there, scalars are there. Vectors are having magnitude plus direction. Scalars are having only magnitude. That means no direction. Right. First, you write vectors and scalars are physical quantities. Then write vector. Next heading vectors or a vector. A vector. A physical quantity which has a direction and magnitude. Is called a vector. Sometimes we call vector quantity. Most of the time in old books like that, they used to say vector quantity. Normally vector is enough. Now examples for vectors. First one, number one, example, number one, this is under vectors. Displacement. Displacement. Number two, velocity. Number three, linear. Number three, linear momentum. For O-levels, you used to say momentum. Linear momentum. Number four, force. Number five, some other examples can be given. Rate of change of momentum. rate of change of momentum. Don't consider that much about that, I'll explain later. Then electric field intensity. Electric field intensity. Under that, if you want, you can write 7. Magnetic, MAGNETIC, field intensity. 8th one, gravitational field intensity. Field intensity. There are some more. At the moment, we can explain, but I can give the examples. But if there, you note it down, if intensity, field intensity word is there, then it is a vector. Later we learn magnetic flux, then magnetic moment. Those are not given here. Right. Then scalars. Scalars. Under that definition of scalar quantity which has only a magnitude. Only a magnitude is defined as a scalar. Within brackets you write there is no direction. There is no direction. No direction there, then it is called scalar. Example. We can give you a lot of examples. Number 1, distance. Distance. Number 2, time. Time. Length. That is length. When we consider length, we can go for area also. Because length 1, length 2, like that, we'll say rectangle. This is the area. Then write area, volume, work done, energy everything what we consider like that, those are more than that. Mass, those are scalars. I'll give a small, no, before that, better to write like this. Physical quantity, vectors, scalars, only magnitude, magnitude plus direction. Right. Now we'll go to next situation. Here what we are going to do is consider vectors in a different way. Now, before that, I'll explain distance and displacement. Distance is normally for O levels the shortest distance between 2 points. That is displacement. But distance is if you consider any path from A to B, like that there is a path. But there are many paths. All these paths are concerned, they have different lengths, L1, L2, L3, L4. Those are called the distance. The length of any path is called a distance. Then write distance. When 2 points are considered, when 2 to reach from the first point, any path is concerned, the length of that path is called its distance from A to B. There are several paths. Each path has its length. That is called distance. Right. Then draw it and say L1, L2, L3 are distances. L3, L4 are distances with respect to each path. With respect to each path. Then you have to draw that. Now, we'll consider distance. The shortest distance, that is displacement, not distance. This distance A to B as the shortest one. Then write the shortest distance is the straight line from A to B. Therefore, that is the displacement. But we have to tell the direction. Direction is from A to B. Direction is from A to B. It should be shortest distance, then it is a straight line. And direction must be said. But O levels, they don't mention that much the direction. Right. Now we'll go to the vectors again. In vectors, this is another easy method I will tell, or I'm going to tell you, to find a vector. That means product of a vector and a scalar is a vector, except one situation. Product means multiplication. Then write a product of a vector and a scalar or scalar and a vector is a vector except in one situation. Except in one situation. Now we'll consider what it is and how this is to be written. We can say vector into scalar is equal to a vector. Got it? Vector into scalar is a vector. That is what you had right. Now we'll see, except one situation, that is pressure. According to our definition, that's mean for A levels, this where pressure is also, we can say a vector, but it is not a vector. That means this theory is wrong in that place. That's why I say, except in one situation or one occasion. Now, we'll consider first one, velocity. Velocity, displacement divided by time. That is velocity. We can write it as displacement into 1 over time. 1 over values are normally called reciprocals. So we can say reciprocal of time also. Then velocity. Now consider the two factors separate of physical quantities. This is a vector. This is a time is, or 1 over time is scalar. Vector into scalar is a vector. So therefore, velocity is a vector. We can come to, in that way, we can come to a conclusion like that. Note it down. Then we'll consider another one. Linear momentum. Linear momentum. That is equal to mass into or mass into velocity. So then mass is a scalar into, then velocity is a vector. Scalar into velocity vector is a vector. So therefore, linear momentum is a vector. Linear momentum is a vector. Right. Then we'll come to force. Next one is force. Now we'll consider force. Force is mass into acceleration. Right? But acceleration is also a vector. If you want, we can do it first. Acceleration is equal to change of velocity divided by time. That means change of velocity into 1 over time. This is a change of velocity. I explained in the first unit. If anybody wants, I will explain it again. Change of velocity is a vector into scalar. Then this is a vector. If you want to know change of velocity, I'll write it. Change of velocity is equal to final velocity minus initial velocity. So velocity difference is or vector difference is a vector. Vector addition like that. Then write any velocity or any vector difference is a vector addition of two vectors is a vector. Addition of two vectors is a vector. Now we'll consider force. Now force is a mass into acceleration. When you consider mass is a scalar and acceleration is a vector. Scalar into vector. So this is a vector. So then we can say force is a vector. Force is a vector. Then we can consider Force is a vector. Now I'll come to pressure, but it is not a vector, but it seems to be a vector according to this. Pressure is force divided by area. That is force into 1 over area. Then according to this, force is a vector into area is a scalar. But according to that previous theory, this is a vector. But this is wrong. Pressure is not a vector. But according to theory, it comes like that. This is the only situation where that equation or the theory is not valid, invalid in this situation. Remember, we can't apply for this. If you apply it, we get it as a vector, but pressure is not a vector. Normally, the best example, when you consider pressure of a gas. So, pressure of a gas we can say in pascals, but we don't say any direction. The pressure towards north, pressure towards east, like that we don't say, since it is not a vector. Then note down this. Now, this is one situation, on only situation this goes wrong. Now we'll come to again vectors. Magnetic field intensity, I said. Those we have to consider under those sections. Magnetic field, then electric field, and the other they are only the thing is the right vector. So then speed, don't write, divided by time. Distance into 1 over time. Before that, no theory like that, especially the product of two scalars is a scalar. Then write the product of two scalars, is a vector. Product of two scalars is a vector. So that means scalar into scalar is a scalar. Even you get another product, that is also scalar. Understood, no? Right. Then you write this one first. After that, you try this. Then it is a scalar into scalar. Scalar into scalar is a scalar. Scalar into scalar is a scalar. Next one. Product of two vectors, right? Product of two vectors is either a vector or a scalar. Either a vector or a scalar. It depends on the situation. So then we can't say two vectors are concerned. In common, it's a vector or scalar. It can be a scalar or a vector. Right? So therefore, those things are not asked for physics A levels. But remember, vector into vector, not always a vector. It may be a vector or it may be a scalar. If you are doing maths, then those students have to do this in advanced ways. So therefore, in deep, they have to study. Then we consider vector into vector is a cross product of vectors. Then answer is a vector. The other one, vector into a vector, dot product. Then it is a scalar. Those are not, those two what I said are not in physics syllabus. Math students will learn later. This section is easy for math students, therefore later. Right. Now, we have to, if you want, I will give you example. So then, work done. Work done. Force into displacement. Sometimes they say the direction, the force acting or move, the object moving. Direction of moving direction means displacement. So therefore, this is a vector into, this is also a vector, question mark, but work done according to this either vector or a scalar. So this is a scalar, not a scalar. Vector or a scalar. If you want, better write a vector or a scalar. Energy also scale. Next one. Notations for vectors. What do you mean? Right. Right. Now, when you consider about vectors, notations are there. Notation is, we can say simply, either we can draw certain bar on it, or new method is small arrow on it. Then A is a vector. Very old one, I will give you this as the one. Old ones, A, just bar, or below that, there is a wave drawn. Those are all notation. This is our new notation. Then write, if A is a vector, it can be written as, let English letter simple A, and draw a small arrow above it. Above it, as shown on the board. All notations simply above that line is drawn a bar, or there is wave drawn below that. Those are all notations. You can write simple B like that. Example, A is force of 5 newtons towards north. When you are explaining it, we have to write the magnitude. This is the magnitude. This is the direction. Direction. Just write it. A This is how we are writing it. Vector B. A velocity of 10 meters per second towards south. Towards south. So then a velocity of this is magnitude, this is direction. Right. Now, a vector can be represented by a straight line. A vector can be represented by a straight line. That is called geometrical representation. Then write geometrical representation geometrical representation of a vector. That means a vector can be represented by a straight line. Then write a vector can be represented by a straight line. straight line. But there are three conditions for that. Then right, there should be three conditions to satisfy that. There are three conditions. Number one, magnitude of the vector is the length. Magnitude of the vector is the length of the straight line according to a scale. We can, if we say distance of 5 kilometers, we can draw a certain straight line up to 5 kilometers. Then we have to get a scale and write. 1 centimeter is 1 kilometer. Then for 5 kilometers, 5 centimeters. Like that, we can reduce the length. Second one, the direction of the vector. Second one, the direction of the vector. Third one, direction of the vector. That means from one place to another place. Then right, it should be drawn by an arrowhead on the straight line. Arrowhead on the straight line. Now, third one. The direction, it actually works. That is called acting direction. Acting direction. All three are there, then it is a vector representation. We'll say example. Example, we want to draw a 5 Newton. Then example, you write it, note it down. 5 Newton towards east. Right. Now consider this is denoted by straight line AB. After that, I'll give you some notation again. Then first one, the magnitude must be, first one is satisfied, number one, direction. Sorry, magnitude. So then you can draw according to a scale. We'll say 1 Newton is equal to 1 cm. So this is 5 cm. it should be, it was like that. It could be like this. AB, AB. Any direction you can draw. AB. So then you can draw again A here, B here. All are 5 cm, 5 cm, 5 cm, 5 cm. Then second one. 1 plus 2, both are considered the direction and magnitude. It should be either AB or opposite one AB. Then third one, 1 plus 2 plus 3, all are satisfied. The direction from first one to second point A to B must be east. That means A to B must be in the direction of east. Then the correct one, this one only, AB. That time you put the arrowhead here. So then you can draw it at once. Right? That is a, don't do anything. Before that you write, when a vector is represented by AB, straight line AB, it is denoted as AB and draw an arrow above the two letters from A to B as shown on the board. Sorry, as shown in the book or on the paper. Right, next situation. One by one, we can say, but there is no need to draw like that. At once you can draw it. We'll say, now another example. A is a vector and it is represented by the straight line of vector AB. Then write A is a vector and it is represented by the straight line AB as a vector. Then remember these things. Vector A must be vector A magnitude. Magnitude, that means the value. Must be equal to length AB. AB length. Or we can write magnitude of, if you have a problem of writing magnitude of it. That is number one condition. Number two condition, direction of A must be parallel to AB. Number three, acting direction of A must be equal to acting direction of AB. That means A to B. Then vector A is equal to vector AB. These three conditions must be according to that. Means the magnitude means the value. According to a scale must be equal to AB length. Those two must be the direction of the vector and AB must be parallel. Acting direction will say this is to the north, then north A to B must be the same direction north. Those three conditions are satisfied, then A is equal to AB. Some more examples I'll give you. First, you note it down. Students, you got now? If you have a problem, you send me, better to call. Right. Then write equal vectors. Next heading, equal vectors. That means two vectors are equal to each other. Now we'll consider AB and PQ are two vectors. Those two are equal then. We'll say then AB, vector AB is equal to vector PQ. Then what are the conditions to be met? Those three actually. Number one, magnitude of AB, don't write, must be equal to magnitude of PQ. Magnitude is the, what do you call that? The value of the vector is called magnitude. Then write first magnitude of a vector. Magnitude of a vector is its value. Magnitude is concerned first one. Now AB is equal to PQ. Then AB value must be equal to PQ. The lengths are equal. Number two, AB must be parallel to PQ. Number three, acting direction. Acting direction. A to B must be equal to P to Q. Those three conditions are like that, then only AB is equal to PQ. No doubt.
වර්ණනාකාර දෙපාර්තමේන්තුවේ මාධ්‍ය ප්‍රකාශකවරයා ලෙස කටයුතු
Now we'll do certain example. First you write the question like that, the example. ABCD is a parallelogram then prove that vector AB is equal to vector DC. Number one. Number two, vector DA is equal to vector CB. These two you have to prove. Now I'll do the question. First, this is a parallelogram. Opposite sides are parallel and equal. If I ask what is the definition of a parallelogram, then most of the students are saying opposite sides are parallel and equal. But actual definition is not that. The opposite sides are parallel of a certain opposite sides are parallel, then it is a parallelogram. Then special cases, rectangle is a parallelogram. Square, parallelogram. This is also parallelogram. Those are special cases. Then here, number AB is equal to DC. Because opposite sides of a parallelogram. That's it. Those are equal. Then AB is parallel to DC. Second one. Third one, direction A to B towards that direction is equal to direction D to C. So therefore, vector AB is equal to vector DC. Second one, vector DA is equal to CD. I think you have completed now. Then I am going to show is the next one. That is number 1, DA is equal to CB. Number 2, DA is parallel to CB. Third one, direction or acting direction. Direction D to A is equal to direction C to B. Therefore, vector DA is equal to vector CB. Right. Now this is how you have to write the two vectors. Now I'll teach another one. That is called negative vector. Negative vector. When we consider negative vector of any vector, first two conditions are the same. That means vector is concerned magnitude must be the same. And second one, they are parallel to each other. Only the difference is the negative one has the opposite direction of the first one. That means first one is towards north, then negative one is towards south. If the first one is towards east, negative one is towards west. That is the only difference. Then right. Only the difference here is the acting direction. Negative vector direction is opposite to the original, vector's direction. Now we'll consider that. First of all, we'll consider negative vector of, not down, negative vector of, hello. Okay. Class recording class negative vector of AB is PQ. Then negative vector of AB then PQ is equal to AB. Or we'll write out AB is equal to PQ. AB is parallel to PQ. Direction of A to B must be equal to the opposite direction then. Direction of AB is the opposite direction of PQ. Or that means, don't write P to Q. It cannot be P to Q. Then it should be Q to P. P to Q same, both are same. P, Q to P. Then minus AB is equal to PQ. After that, simplifications I'll tell you. First you write it. That means minus of AB is PQ. Then the direction must be A to B must be Q to P, not P to Q. Right. Now we'll consider then write example. ABCD is a rectangle. ABCD is a rectangle. Prove that negative vector of AB, negative vector of AB is equal to vector CD is equal to vector CD. Next one, second one, negative vector of DA is equal to vector BC. You have to prove those two. Right. Now, before that, I will show you some simplifications, easy ones. Simplifications. Minus AB is equal to, minus AB means direction is opposite of AB. Opposite of AB means B is equal to B. Minus PQ is equal to QP. Negative or minus of AB means both are equal but opposite direction. Opposite direction is B. Opposite of PQ is QP. Sometimes minus CD. Direction CD is equal to just minus into minus plus, no? Plus CD, that means CD. Or you can say minus negative CD. Then we can consider it as minus DC. Why? You change the directions. Then minus DC is again change the direction. DC. Then CD. Same thing, minus minus plus, then CD. Note down that also. Other one you can do. That means if you want, you can write like this. dA is equal to CB. dA is parallel to CB. Acting direction D to A is equal to acting direction C to B. C to B. That means D all are concerned. dA is equal to CB. So minus dA multiply is equal to minus CB. Minus CB is BC. Another method. Right now, I said about what's happening here. We can write like this. Next one. Now we can understand what is negative vector, how to consider two vectors are equal, how to get one vector is opposite one or negative vector, all you can understand. Now, vector addition. Heading is vector addition of two vectors. Better write first vector addition. After that, below that you write addition of two vectors. Addition of two vectors. You have to get two vectors. You can't have just like mathematics or arithmetic or algebra. You have to do it using geometrical representation. Because direction is involved. Right? There is a rule for that or theorem. Right? We'll say A and B are two vectors. So A and B are two vectors as simple A is represented as, or then simple A is represented by the vector AB and the vector B is represented by vector BC. Then the addition of these two vectors A plus B is represented by the vector AC. But you can't understand what I said. To get this one, you have to consider a triangle. Right? The first one, A. In a triangle, ABC, the AB side must represent the vector A. From the end of B, the second one should be drawn. BC. End of this. This is vector B. Then the vector AC represent vector AC. That means first point and last point are connected. Then you get a triangle. So then AC is equal to vector A plus vector B. We will put it in words. When two vectors A and B are represented by the two adjacent sides of a triangle, two adjacent sides. As AB is A and BC is B, then the vector AC gives the addition of the two vectors. That is called triangle formula or triangle theorem of vector addition. Then write heading. Triangle theorem of vector addition. Triangle theorem of vector addition. Then write, next line you write. When symbol A and B, write like this, A and B, are two vectors and they are represented by the two adjacent sides of a triangle AB and BC, then the vector AC represents then the vector AC represents the addition of the two vectors A and B. That means vector A is represented by AB and vector B is represented by BC. Then addition of A plus B is represented by vector AC. Draw and write it. This is not needed. These are not needed. you can get the recording. Most of the time from this week onwards, you can, after 2 days or 3 days, maybe even after 1 day, you can get all those on the YouTube also. Right. Now, very simple. AB, BC, then AC. Remember one thing, you can't add two vectors just. Always you have to use the triangle theorem. Example. A car travels towards north 3 kilometers, then towards east 4 kilometers. Simple case, simple A. Find the displacement of the car. Find the displacement of the car. Now, what I thought, you might think there is a difference here. No. The reason is the direction. The car first moves towards north 3 kilometers. Direction is there, magnitude there, therefore it's a vector. Again it turns and moves to the east 4 kilometers. Direction is there, magnitude is there. Then two vectors. Displacement is the two positions now. Now physically if you draw, it went to, this is north, east, west and south. So then first it went to north, then went to east, and their positions are, we'll say, x, y now, just to understand. So displacement is, this is the displacement. Placement of the car. X to y. This is just a diagram. Just a diagram. Then draw. This is not a vector one, almost. So displacement is x to y. Car is x to y. Then draw it. That is not the vector addition. To understand, I drew it. But hereafter, I'm not going to draw like that. If you ask, I'll draw it if you ask. Otherwise, I don't draw. Right, now, actual story, now I'm going to do. So then first one, there should be a triangle. Vector AB is 3 kilometers to the north. Then vector BC is 4 kilometers to the east. Then vector CA is the addition. Got it? That is the addition. Now, we'll consider in this way. Now we have to draw AB from A to B. North is here, we consider north as like that. So A to B, 4 CA. Why? 1 cm represents 1 kilometer. That's my scale. Then 4 centimeters. After that, BC, no, first one 3, sorry. First one is 3 centimeters. Then AB, then this is 4 cm. BC, connect A to C. This is 90. You can draw it geometrically. That means first you draw, write the scale. Then 1 centimeter is equal to 1 kilometer. Then 3 kilometers is equal to 3 centimeters. 4 kilometers is equal to 4 centimeters. First draw this line. Then normally standard way of doing it, you get to the compass, draw a straight line, keep it here and cut for 3 centimeters. From there, draw the 90. To draw the 90, you can use the protractor or you can use your geometry knowledge. That means that straight line, here you keep this is B. From here, you are cutting the same like that. After that, what you do? Same distance is placed here and cut like that. Then connect this. That is 90. That's O-level geometry, but you use the protractor. After that, mark 4 centimeters. So compass you can use for that too. After that, A and C, using a straight line, these lines can be connected. Then you have to measure this one. The distance is, whatever we'll say, distance is 5 centimeters. Then this is 5 kilometers. If you want to get the angle, use the protractor and measure the angle. But I will tell you that can be done at home, draw and see. But now I am going to say mathematical method. Using maths, how to get this. It's also very simple. What you do is, now this is 90. Therefore, ABCD is what? Sorry, ABC is a triangle. Which triangle? Right angle triangle. ABC is right angle triangle. Therefore, we can use Pythagoras theorem. Then AC squared is equal to AB squared plus BC squared. Right, it is using the Pythagoras. AB is 3, these are magnitudes. 3 squared plus 4 squared. 9 plus 16, that is 25. That is AC squared. Therefore, AC is equal to square root of 25. You normally plus or minus is there, but we consider only plus CA. Therefore, 1 cm is equal to 1 kilometer. Then 5 cm is equal to 5 kilometers. So, this is 5 kilometers then. Actual story 5 kilometers. After that, you have to find the direction. To find the direction, remember these two are going to the clockwise. The other one opposite direction is anticlockwise. This is to the opposite way. Then we have to find the angle. Normally angle can be represented as theta or alpha. Then you have to consider tan values. Next week like that, I will do some trigonometry to understand that. Now consider tan theta, right? But tan theta is equal to opposite divided by adjacent. So then opposite one is BC divided by AB. That means 4 divided by 3, tan theta. Then after that, normal method, if you want to get the correct value, tan theta is equal to 1.3333 like that, divide and get. Then after that, you can find theta from the book. I don't think for O levels you have done like this. So therefore, you can use like this. Theta is equal to inverse tan inverse. Tan inverse means just like a statement. You just get the angle. It's a command. You have to get the angle using this. But we don't want to find. Then the answer is the displacement of the car is 5 kilometers, right? Towards the direction of tan inverse 4 by 3, tan inverse 4 by 3, from north to, this is north, this is, direction is east, north to east. Then angle tan inverse 4 by 3 from north to east. North to east means you are going towards theta, stop the place according to this one. That is how you do. First you write up to this. This statement will be given by me, the angle. Right up to that. I think you have come up to this. Here, how to write the answer. The displacement of the car is 5 kilometers making an angle of, you write like this, tan inverse 4 by 3, tan inverse 4 by 3, from north to east. From north to east. Never write this angle is northeast. Northeast, if it is northeast, this angle is 45. I'll give you an example for that also. A child walks 400 meters towards south and then again 400 meters towards west. Find the displacement of the child. Find the displacement of the child. Normally, to understand this in a proper way, I will draw this north, south, west, east. This is 45. Again 45 from here. All the angles are 45. Normally, these directions are written from the line SA. South, north or north, south. From north to east, north to west, south to east, south to west. So then, south to east, southeast. This is called southwest. This is called northwest. This is called northeast. First draw it to understand it in a proper way. Then we'll do the question. A child goes to south, normally towards south, P, Q, down towards south, 200 meters. Again, this is south, this is west. West 200 meters. This is R. Then first point and last point you have to join. That is the vector addition. That is the displacement. Child bursts here, child is here now. Then this is the displacement. Shortest distance between the 2 points towards one particular direction. This is 90. Then using Pythagoras theorem, then we can say PR squared is equal to PQ squared plus QR squared. Then PQ is 200 squared plus again 200 squared PR squared. Actual values I'm considering. Then this is 4, 1, 2, 3, plus 4. Then altogether 8. Or we can write it as, that is PR squared is equal to 400,000 plus 40,000, then 80,000. This can be written as 8 into 10 to the power 4. Then PR is equal to square root of 8 into 10 to the power 4. Or you can write it as 2 into 4 into 10 to the power 4. 8 is 2 into 4. Then that means square root. This is square root of 2. This is square root of 4. This is square root of 10 to the power 4. But there is no need to write like this. I just, square root of 2 we don't know how to say at once. Square root 2, 4 is 2. 10 to the power 4 is 10 to the power 2. That means this is square root of 2 into 200, 100 into 2, then 200 square root of 2 meters. That is the distance. Square root of 2 is 1.41. Like that you can simplify using that. Then direction. He started from here, now there. This is theta, or we can say alpha. Any angle. Tan alpha is equal to opposite of divided by adjacent. Then QR divided by PQ. QR divided by PQ. Then we can come here. Tan alpha is equal to QR 200. QP also, or PQ is also 200. 200 divided by 200. That is 1. Tan alpha is 1. Alpha is tan inverse 1. Actually, 1 tan value is seen. This angle is equal to 45 degrees. So that means if the tan value is 1, the angle is 45. Remember that. Right? Those values I'll give next week. Because before going to the other part, I'll do some trigonometry next week. Right, note it down. using geometry, that means according to a scale, you can draw like that. There you can say, don't say 1 centimeter is equal to 1 meter. So it's feasible one. So then 5 centimeters or 40 centimeters is equal to 1 centimeter is equal to 40 meters scale. Draw and see. Then there is no need to count like that or calculate like that. Right? 40 meters. So then 1 meter is equal to 1 over 40 centimeters. Then 200 meters is equal to 140 into 200 centimeters. 40, that is 5 cm. So then 200 means 5 cm, 5 cm you use. Any scale you can select. That is what I selected. Tan value is 1, that is 45 degrees. How to say the direction now? Here you tell the direction, then write the displacement of the final answer. The displacement of the child is 200 square root of 2 meters, 200 square root of 2 meters towards southwest. Why this is 45? The 45 is concerned, there is nothing to say about anything. 45. So 45 from here, 45 is southwest. That is your answer. Next one. Next one. A car travels 2 kilometers to the east. Then again 3 kilometers to the east. Find the displacement of the car. In this situation, there is no need to consider triangle. The reason is, see, we'll consider AB. AB is concerned A to B towards east, this is east. How many? First it was 2 kilometers. Then from B again to the same direction, 3 kilometers. 3 kilometers. Then 2 points. A, the person is here, the car is here. The car is here now. So displacement is A to C. That means vector AC. Then AC is equal to AB plus BC. Normal calculation. We have straight line, there is no need to have no triangle also. So AB is 2 kilometers plus 3 kilometers, altogether 5 kilometers. That is AC. Then you have to say, tell the direction. displacement of the car is to the east 5 kilometers. Very simple, not it down. Next example. A car is moving to east 5 kilometers, then turn and moves to west 2 kilometers. What is the displacement of the car? What is the displacement of the car? It is first, it's moving to the east, AB 5 kilometers. AB is 5 kilometers. Then coming back 3 kilometers. B to C, 3 kilometers. That means BC is 3 kilometers. Then displacement of the car A to C, AC. AC is equal to AB minus BC. AB is 5 minus 3, 2 kilometers. That's 2 kilometers. Direction A to C is east. 2 kilometers to the east is the answer. This is the first session of vectors. Then second session, I am considering about the other things related to the vectors. Thank you.